Hi there. Today let's see how to build SRT on Windows 11. I have a pretty clean installation of Windows here, and some tools are pre-installed. So let's start up by opening the browser. We have Microsoft Edge here and go to github.com and find the SRT project there. So if you know the full URI, it's just quite simple, hivision/SRT. So you can just go directly there, or you can find the repository using GitHub search, and SRT is very likely to be on the top. This is the main page for GitHub, and there is some documentation section. So for example, getting started with SRT, and there should be how to build SRT. So build instructions, special sections. This build instructions mainly concerns Linux-based devices. For Windows, there is a separate document describing various options how to build SRT. Although the requirements are quite similar, so you need a compiler, you need CMake to create a build project. Then using compiler, you will build the project. And project has certain dependencies. First of all is OpenSSL. It's a library that provides encryption. Some other libraries are also supported, like embed-TLS or GNU-TLS, but on Windows it's OpenSSL. That's what you will need. And well, multi-threading we have now by default C++11 with the latest compile, so that's not an option. This we also don't need. So let's go to Windows build instructions. The document is pretty big. Don't be scared, because it's just tries to cover all possible options how to install dependencies here. So let's start with prerequisites. So build tool dependencies. We have 3 main dependencies: CMake, Git, and Visual Studio for compiling and linking. So each of these tools has a hyperlink, so you can use it to go to the exact project and follow installation instructions there. So for example, CMake, we have the main website, download latest release, and you can find platform Windows 64 install and just download it and run to install the same, or pretty much the same for Git. So you would need to find like download section and Windows, and for example 64 Git for Windows setup. Just download it and install it. Visual Studio is bigger, so it's like quite a complex tool. There is a free version which is community. Other versions require a license key, so you need to buy it. Let's start by downloading Visual Studio, because it will take the most time. We already have installer being downloaded, and this image of Windows 11 operating system, I believe, already has some Visual Studio installed, so probably it will just open the existing installation and show which packages and which tools are installed. So Visual Studio installer, continue. Now we are okay with downloading the installer itself. It will take some time to run. Okay, we have Visual Studio installed, although it's a bit older version. So I'm not sure if I need to update it right now. It will take time because I basically need to modify it. Let's see which options do I have. So you would probably need to like follow instructions in installing it, but the screen you will have is quite similar, where you need to just select which tools you need. So I don't need Azure, don't need .NET here. This also don't need. So desktop development with C++, that's the main set of tools required. And on the right hand side we see what's included there. So C++, core desktop features, also CMake for Windows will be installed. CMake tools for Windows. I'm not sure if it will be integration or standalone CMake. but I guess that should be enough. So just let's click install while downloading and modify the Visual Studio version. So now it is being downloaded and then it will be installed. Again, it will take some time. Meanwhile, I believe Git will not be installed by Visual Studio, although you might, probably there was some kind of checkbox for it, but I believe there might be not. To install Git, we have just Windows setup. It's probably the most straightforward way to do it. Let's just download it, open it. So next, default path is okay for me. By default, it is integrated with Explorer, and I believe it's Windows Terminal as well. So just next. So this, well, better to use also default because they won't recommend what's bad for you, right? Next. I don't want to read that much. Too many options for me. Just install. Finally, it's been installed. No, it also takes some time. So it's good already to have several processes in parallel. Okay, Git has been installed. Finish. And so what we can use is just Windows Terminal. Okay, but we have terminal. Let's check if we have Git. Yeah, so Git version 2.38 is there. Now let's wait until Visual Studio installation finishes. It's almost there. Just want to check if CMake is also available in the terminal, and we will move further. Okay, Visual Studio installation has been finished. Now let's check CMake. We'll first try without reloading the terminal. I guess it will work. Let's see. No. Okay, then let's reload the terminal. No, not available. Okay, then let's just install CMake ourselves. Again, downloading the installer, 64-bit. Okay, let's run CMake installer. Next. Can accept an agreement, reading carefully. Next. Then add CMake for, well, all users or current user. Well, current user, let's don't be current user. Installation paths, okay. Install. They should be quite quick. Finished. Let's check. And finally, it's here. So 3.25, it's a good version. So the minimum requirement of SRT is 2.8, I guess, should be listed there. Thus, we have CMake and Git installed. Visual Studio is also here. Build tool dependencies are satisfied. We can move forward. Now we have external library dependencies, and for Windows, it's mainly the cryptographic library. There is an option to just disable encryption in SRT with the CMake build option, and you won't need any encryption library. That might simplify the build, but you will have encrypted connection, which is also an option for SRT, but it's better to have it. So we need basically OpenSSL. The question is how to install. There are several options. If you go to this table of contents, we see preparing dependencies and cryptographic library, installing OpenSSL. And let's go again back to the table of contents. So we have basically at least 3 versions. So we can use VC package. VC package might be useful for developers because it allows to build and install other dependencies. So I guess we will not go this way. Then we can use an installer instead. So using an installer. So we have, for example, link to 1.1.1 version. It is already not working. So you would need to find OpenSSL download, for example. Download. it happens this way. OpenSSL.org, download OpenSSL for Windows. Here we can download, I guess, source files and build ourselves, which we don't want to do. Let's check another link. SourceForge. Have download 1.1. Windows 32. What else do we have here? See all activity. OpenSSL for Windows website. I think I will just go another way. So the link is invalid, needs to be fixed. I will just use instead, it's not shown here, but I will just use winget. So winget is available on Windows 10 and Windows 11, can be installed via the Windows Store. If you don't have it, so I guess Windows 11 has it by default, but if you don't have it, you can just install it in the Windows Store, and it's just winget install in Google, and I guess you will see. So get the app installer from the store. So it's called app installer in the store. Install it. It's installed on this machine, and you will have winget. So winget. You can search OpenSSL here. I'll make it bigger. Yes, I agree. And we have OpenSSL in here. So it's the version, I'm not sure why it's 1.0. If we do winget show OpenSSL, then it will show the manifest, and in the manifest you see that the version is 3.05. So I guess this 1.0 is probably manifest version. So here is the valid link. You can like spend some time find it on Google, which is might take some time, but I will just install it using winget. Winget install OpenSSL. The main question will be that we will need to know the path where OpenSSL is located to tell CMake to use it and to tell it to the SRT project. Basically what it does is just downloads the installer. Okay, and runs it instead of me. Well, that's pretty handy actually. Not that bad. Okay, installed successfully. Where it is, it's a bit of a question. I would expect it in program files, OpenSSL. Yes, it's here. Okay, that's great. That's great that we have it here. Then go back to the instruction. What else do we need? So cryptographic library is installed. Threading library. So for Windows, we will just use C++ 11 threading. It's recommended. There is another option to use bthreads, but it's just like a port from Linux. So we don't really want it. And this way we just don't need to install anything. It's available with the compiler. So that's it. Let's go to build an SRT and follow the steps. First of all, we need to clone SRT. So we can clone specific version using the tag name, or we can just like avoid this path, and the master will be cloned. Anyway, let's go to SRT GitHub. And another way to get the link is by using this button, so code, and it's the URI to the Git repo. You can just copy it and like manually paste to the git clone command. So here again, git clone. Git is the tool. Clone tells what operation to perform. Then there is URI of the Git repository. Then it's optional parameter, but it's target folder where you want to store your repository. By default, it will just use the same name, so just SRT. And branch Again, it's optional, but you can check tags of SRT repo. It's mainly bound to the release version available. The latest one is 151, so we can just, for example, use this naming to check out exactly that version. So I guess let's do it. We have we are located in the user folder. I'm not sure where. I guess I will create a projects folder and go there. Now git clone, so branch 151, a repository name, URI, and target folder, let's call it SRT, for example, 151, just to have a different name for it. As we have Git already installed, we are cloning it, and if you check out the folder, you have SRT v151 there, with all the source code from the GitHub. We don't have binaries here yet, we just have the copy of this repository, and to be more specific, this 151 version, or 151 branch. Okay, back to instructions. So we went to the folder, some notes. Additionally, if you, for example, didn't use branch tag name, or you already have a working copy of the repository and you want to switch to another version, to the latest master and so on, you can just use checkout. And of course, for further information on Git, just you can go to git.org, for example, and find, okay, sorry, not git.org, gitscm.com, and find some documentation there. So, for example, reference for available commands to study, or some resources to check out working with Git, how to work with Git. Now we have the sources, and we want to build SRT. So to build it, we need CMake. CMake will prepare solution files for Visual Studio, will list all the sources required for the project, create the project for Visual Studio, and later on Visual Studio will use this project to build SRT. What's important here? First of all, we need to specify, no, it's not the bit threads, we need to specify OpenSSL. I don't see it here. Maybe it will just find it itself. Let's check. So there is a way to build, to create all the sources, all the project, sources in the same folder. To do it, you just call CMake by using dot and slash, and I guess without slash would also work. So it will tell CMake to generate build files in the same folder. But I prefer to create a separate folder, name it build, because there will be quite a lot of generated files, and I really like to just, for example, if I don't need them, I just remove the folder, and that's it. That's easy to clean. And this way you need to specify, again, we call CMake, and tell that the CMake lists txt file, which defines the project structure, is located one way above the current folder, so in the root of the project, and we are building from this folder. So run it. It automatically detects Visual Studio 2022, which is the only compiler installed at the moment. Otherwise, we would have to specify which version do we need to use, or it will just select some default one, which is also okay. So it basically generates SRT with basic or the default configuration, and outputs configuration, so building for Visual Studio 2022, checking for compile support. That's not very interesting. What's interesting is OpenSSL. It's found in the folder that we've installed. So that's great. We have OpenSSL installed and found by CMake. The rest is just simple. So we have now in the build folder, we have I need to run it manually. We have generated files. Let me go to that folder. Users, user, projects, SRT, build. So we have this folder created, and CMake generated all the sources, all the project files here. The main project file is called srt.sln. SLN stands for solution. Let's see it here, srt.sln. And from this point, there are two ways. You can open it in the interactive development environment, Visual Studio. So this exact solution. And we'll have all the projects there, all the sources required for this configuration there. And you can build it from this IDE, let's say. But it will ask you to sign in, configure the look you would like to have. Takes some time to load. So it tells you what's new, and okay, still loading the project. Sorry, the project is on the right hand side. I'm used to have it on the left hand side, so a bit different. So basically, the main library project is srt_virtual, and there are two options to build: shared library or static library. And then by default, you should also have sample applications, which is srt-live-transmit, for example. On top, you can select the build type, for example, debug or release. Release configuration just has more optimizations of the code, so it's expected to run faster. So let's build a debug version in IDE, just as an example. The project automatically knows dependencies that it also needs to build. So for example, building this project will also trigger building SRT virtual. I guess SRT static will be built, but it's like a bit of a fake project. And SRT support virtual, but SRT file transmit, for example, will not be built here because it's not required, and SRT tunnel also is not needed for this project. So it's kind of faster because you don't need to build everything. And you see, build succeeded. Well, you can of course run from here, but you can find the binary outputs in the debug folder. So build, where the solution is located in the debug folder, then we have srt-live-transmit build here. So now let's make the same build, but release configuration this time using CMake. That's also possible. So with CMake, we need to tell that we now, instead of generating solution files and project files, we would like you to build, to actually run the build procedure. And to do this, we type in the build flag and then tell the folder where the solution is this time. So this time it's not like two dots telling where the CMake list.txt file is, but the current folder. And build type is config and, for example, release. Okay, guess that should be enough. So now it will just do everything in this terminal. The difference is that it builds everything. So it will build all those projects here, which is, well, kind of okay. Not a big deal. Yeah, the build has finished, and now we have a new folder called release, and here we also have srt-live-transmit, SRT file transmit, and SRT tunnel, so all applications that were included in the project. Now, what is also important to know, that there are certain build options in SRT. You can find them also in the manual. Let's go Well, we can go to docs folder and find SRT build options. So this SRT build options allows to configure the build in bit. So for example, by default, the bonding feature is not included in SRT, it's disabled. So you can build SRT with bonding enabled if you need to. Then well, some other things like heavy login, enabling static, enabling applications, busy waiting. Well, you can find the description in this document. I would say that maybe enable bonding might be interesting. So let's see how we can use enable bonding to specify it in CMake. So to do it, we need to reconfigure the build files. So again, we need to address the CMake list.txt file, which is located one folder above. We are referencing it with 2 dots, and then we set CMake build option, which is done using minus and D, uppercase D. Then we just type in the option. In this case, it's enable bonding, and then we need to type the value. So here is the default value. So on off, most of the options are on, either on or off. So let's type in on, because we want to enable it. And you should see the output of the configuration here. It should show you that bonding is enabled. For example, previously, if we scroll up, and there should be there is enable bonding option, and it tells you that the configuration was to disable the bonding functionality. Now we have similar, but now it's enabled. And if you run the build, so build current folder, and then config release. I believe 1 minus is also, no, 2 minuses. Config release, and we this time are rebuilding the project because it has now new files to compile, new files to link. So it's again takes some time. Okay, now it's built. Let's talk a bit about how to work with srt-live-transmit. srt-live-transmit is a command line utility. So for example, if you run it from Explorer, you will just have command line like terminal shown for a few seconds or milliseconds, and that's it. Because it's command line utility, it doesn't have a UI. So instead, we need to go to the terminal, and for example, let's take the release version. So release srt-live-transmit. You can just run it from terminal, and you see the syntaxes of the utility. You can also run it with -- help, so we will get the same help here. So the basic syntax is the following: srt-live-transmit, then you have options, or those options can be also placed in the end because they're distinguished by this minus sign. Then inputs and outputs. srt-live-transmit, what it does, it just has some inputs, for example, UDP or SRT, and just transmits the payload from the input to the output. So for example, from input UDP to output SRT, or from input SRT to output SRT. The options that are available here. And there is also a dedicated document about applications, sample applications, srt-live-transmit application, which provides a bit more insight into how to work with the utility, how to form the URI query for SRT or for UDP, how to, for example, use ffplay in conjunction with srt-live-transmit, and so on. It also should show the query options available for SRT, for example. Those are those options. So in case you want, well, normally you would want to configure certain parameters of SRT, example, latency. Like general use case is just to use latency instead, because it configures both latencies, and if you're not an advanced user, just better to set latency. So an example usage would be to run srt-live-transmit. Then, for example, I have some UDP source. That will be UDP semicolon / and then, for example, now we have two options, so SRT caller or SRT listener. Let me see if it's described in this documentation. Yeah, right, so it's described in this documentation. Well, 3 options, also rendezvous. So caller, listener, and it's the way to establish connection. Imagine listener is just a server that doesn't know the remote IP, but it has some port open for connection. And the general scheme for this would be just to emit the IP address and just to tell, for example, the port you would like to use. For example, I would listen, I would expect incoming traffic on ports on UDP port 4200. The same works for UDP media as well. So this syntax means that srt-live-transmit will listen on UDP port 4200, and it doesn't need the destination IP because it will not send anything. It will just receive stream on this port and take the payload from UDP and, for example, resend it using SRT. And for example, you can define some remote IP. I will take, for example, localhost IP and define port, let's say 5500 something. And then if you want to specify options, you need to start with question mark. And for example, let's tell that I want latency equals to, let's say, 500 milliseconds. The default value is in milliseconds. Then you need additional option, for example. This is done via ampersand sign, but normally from this point of view, it's already a control sign for the terminal, which might run several commands in a line. So you need to put the quotation marks to tell that it's still a string. It's not a command to split on. So let's take some other option, which would be, I'm sure it can be send a buffer size, for example. Stream ID might also, let's take stream ID. So let's say you want to specify stream ID equals, the format of stream ID can be also checked in the separate document, but let's say this is my first stream. So it's the plain format of the stream ID where you just specify the name of the stream. And that's it. So basically, you can run this. Windows will ask you if you allow to listen on this port. You allow access to this port for the application. Then you start listening. If you have some stream on this port, it will be sent to remote SRT listener. To learn more about working with srt-live-transmit, check out another video on this channel called Quick Start with SRT FFmpeg. And also there is a handy web resource called SRT Cookbook. SRT Cookbook, it is located also on GitHub, or you can search it on Google. Here is the link, and it has some handy information about, for example, which applications support SRT, how to get started with building SRT on Windows. Then, for example, how to use Wireshark or T-Shark and so on. And for example, if you go to applications and check FFmpeg, there is also a page describing providing some examples how to use FFmpeg together with SRT live-transmit, for example. That's it. I hope you found this video interesting and helpful. See you anytime soon.